Here to talk about the technology behind phase-shifting applications is Benjamin Young, a solutions architect at John Wiley & Sons. If you were here last year, Svea Sigmund is a colleague of his, and this is the connection. Benjamin is a web and digital publishing and open source advocate who focuses on content and how human beings interface with it and with each other around it. He is currently exploring the edges of a re-decentralized web using annotation, distributed identity, and offline-friendly web apps and extensions. Please welcome Benjamin Young.
All right, thank you, everybody. Let's see if this clicker works. Yep, okay. Hi, I'm Benjamin Young. Better known as Big Blue Hat on the internet. On the internet, nobody knows you're a hat. BigBlueHat.com, Big Blue Hat on Twitter, Big Blue Hat on GitHub, Big Blue Hat on Steam, et cetera, et cetera. I do work for Svea, best job I've ever had. I work at Wiley. We do cool stuff there, or we're trying to, so forgive us our sins if they come up in other people's talks. It's a work in progress. It's only 209 years old. I figure we got 2 more centuries to get it right. This is a quote by Hugh McGuire. I like it probably more than I should. It's in the web publication specification that's in progress. And it talks about the difference between books and the web, and also what they can learn from each other. Books can learn from the web how to be bounded but open, and then he says the inverse about the web, that it's open but needs to be bounded in some way if it's going to be the medium for books. So you all know this bit really well, right? EPUBs are packaged webby things that aren't webby anymore once they're packaged. They're in this zip format, HTML, CSS, JavaScript. It just stays in this little reader box. It can link out, it can do certain stuff. But it's really not distributed over URLs necessarily. You download it to your hard drive or the device's hard drive, and then you open it back off that file system. It doesn't work in a browser. That was a really disturbing moment for me when I first found out about EPUB and was like, HTML, JavaScript, oh, awesome, drag on the browser. And it's like, do you want to download this? It's like, it's on my hard drive. I don't want to download it. I want to open it and see it. So that didn't happen. But sometimes I think that's on purpose, that was done to facilitate reading systems. And a lot of you are nodding heads, so you've been in this bit longer than I have. And it's packaged as a zip file, as you know, which is a proprietary thing that's everywhere. We'll get to that. Web pages, apps, and sites are only sort of like books. They use the word pages, and that's about where it stops. They jump around and point at each other because hypermedia or hypertext or whichever the hyper words you like. They're not exactly books, but they probably could be. That's the theory. And they assume a network connection 9 times out of 10. Offline is also considered an error, and if you've ever tried to get information on your phone when you didn't realize you didn't have a connection, you know that feeling. It's just like, oh, server's gone, you get this dinosaur in a game that you can play if you're using Chrome, or you just get sad face or maybe a cat photo. I don't know. But it's not what you wanted, right? It's this word offline over and over again. And you start to feel like, oh, I'm a bad person because I'm offline. And you're like, wait, I was born offline. Like, this network thing happened later. This is new to me. So maybe, by our powers combined, anybody know this reference? I didn't go find a photo, but look it up. Your grandparents can tell you about it, maybe. Yeah, so Offline First is a movement of web technologists. Make them sound better than they are. They're just people like me at coffee shops. That do progressive web apps, which is like all the new stuff Chrome started putting in the browser about 5 years ago that's finally available for you to use. And 2 big parts of this are offline storage and caching. Those blog posts, I'll put these up online, and you can link to all these things. It's like got hypermedia in it and stuff. Those introduced the world to the phrase offline first in 2013. So it's been a while even since this. And then this big list of awesome stuff is really what that is. It's all kinds of JavaScript and packages and things that you can use to get started with offline apps. So that's a deep end link that you can go to. You can find stuff to kickstart a lot of what we're going to talk about. So these are the reasons. This is probably the important bit. The rest of it you can go back to sleep for. Ignoring the rest of the world is shameful, and I don't think that's just my opinion. A lot of the world doesn't have the internet access that we have in Canada and the US and the EU, and Japan, certainly, my goodness. They're not dealing with how terrible it is to only get 6 megabits per second, right? They're dealing with, like, the internet's up twice a week, and I've got to do something, text family or whatever. And that's unfortunate. That was an understatement. Ignoring our own modalities during travel is naive. Like, we're never online all the time. You weren't when you were on your way here, probably, for at least part of it. Your phone wakes up, connects, and it's like, well, I've got to download all this stuff. And that's exactly what it's doing. It's trying to offline things for you as best it knows how. But we do this all the time, right? We get on planes, we get on trains, we get on automobiles, et cetera. Another great movie. Ignoring our dependence on power and connections is dangerous. There's all kinds of disasters that have happened, not many of them too far away. And that sort of dependence, even if you own a Tesla wall, is still a thing that's a problem most places. But there's some hope, which is always a good part. eHealth Africa is a group that's been at this for a while, trying to build offline-first web tech using CouchDB and PouchDB, which are JSON databases, for replicating data when the network's available, because they don't believe it always is, because they're right, it isn't. And they're mostly focused on healthcare. So they take prescriptions when they're offline, they move drugs around when they're offline, and then when they are finally back online, they send all that reporting, and it orders the new meds that they need, et cetera. So they can still be connected and disconnected and not have to, like, sorry, the internet's down, we're gonna have to help you with your leprosy next week when the internet's back up. It's just not an option. And then there's these kids. Offlinefirst.org also runs these offline camps. This time they're at a mansion. They've been in the woods most times, as you can see there. And there's some in the US and there's some in Berlin. Those tend to be the two places they hang out mostly. But this is a group of people working on exactly what I'm talking about here, which is offline web technology. So if you want to go hang out without an internet connection for most of the time, figuring out how to make it awesome, this is a good bunch of people to do it. And a lot of them are authors of open source tools that make this stuff possible. And this is Max, and his internet is down, and the power's out. And apparently his neighbors are having internet trouble also. That's a gas town in the distance, and they run the cloud. But the cloud is locked. Yeah. Thank you. Thank you very much. Yeah, so let's look at some of the tech that lets you survive Max's world and similar ones. Yeah, Web App Manifest, if you've ever written a web extension or opened one up and dug around in it, or know anything about packaged web apps or some of these other things that have gotten talked about, you're familiar with this manifest.json concept or document or whatever it's turning into. It's very much in progress. Web extensions have one that don't quite match this one. Other things have things that use this name that don't quite match. There's a road in the future where these things all coincide and convalesce and all that, I hope. And basically it's metadata about a web page or a web app specifically that says these are the resources I use, this is what I'm called, my description, these are icons you can use if you're on a phone, you can install these things. Chrome supports them as an install button. So if you have a manifest.json file referenced in a web page or a single page web app, Chrome will give you an install on home screen thing. And really all it's doing is giving you a hyperlink on your Chrome home launcher thing, whatever they call that now. And you tap that and it loads a Chromeless Chrome, because the UI was at least called Chrome at one point. That's all hidden or optionally hidden. And now you're just immersed in this web app. And so it feels like an app. You can switch to it using your launcher. But really all you did was provide a JSON file that says, these are the bits you need to point at. This is my start URL. These are my icons. And what we're looking at next is ways to persist that data when the network's not there. Because that does put an icon there, but you still have to be connected to load the thing. It just gives you an experience that feels more native. The web storage specification, all these links go to W3C specs for the most part. So these are either done or they're very in progress, sometimes both. This defines a basic key value store of just, here's a key and give me back a string. Often those strings are JSON. They're just stored as one big long thing, and then you've got to turn it into something JavaScript can use. Session storage solves for the checking out for 2 different flights in 2 different tabs. Most of us use incognito mode or whatever it's called in your browser because we don't trust websites with good reason. But what it's meant to do is solve the problem that data can leak when you're on one tab into another, and suddenly you're buying flights to 2 different places on 2 different dates as one order, and you're trying to keep them separate and whatever. So this technology can be used for that. The one most interesting, though, for offline first apps is local storage, which is for a whole origin. So w3.org could be storing data for your entire experience across w3.org. And that, because it's tied to that domain name, is super useful for keeping data around when you go offline. And those are mostly just strings. It's that dumb. It's like this key and then a string of something. Does everybody know what a string is? Yeah, okay, just checking. And these examples are like right out of the specs, and I can explain some of them if you want. I don't have to, but we'll keep going. IndexedDB is like an iteration on local storage. It uses a whole lot of ideas from databases in the NoSQL world. Especially, it looks a lot like CouchDB and PouchDB, which is why I tend to like it. It's a bit more than just a key and a string, or key and a value. It lets you index what's inside that value because it's not just stored as a string, it's stored in some meaningful object way. So here we've got a library that we're building. There's Tim's Weaving the Web book, which is a fabulous read if you're into web history, or you can come tomorrow and I'll just tell you about it. This is the ISBN, and I'm indexing all the authors, and I can now look them up and make them unique and stuff like that, or make the ISBNs unique, or however I want to structure that. Whereas with local storage, I don't get any of that. I have to like force it into the key space to make them unique or something. App cache kind of came and went in about 3 years. Got called all kinds of nasty names. But it's a text description document unique in its format on the earth, which is probably part of its problem. That defined, these are the resources you need to take offline if you're going to take this web page offline. And really, it reads kind of nice. It says, this is the cache manifest, this is the stuff that I'm made of. And then to see if the network's available, do this, and then here's a fallback when it's not available. So it reads okay. But apparently, the implementations had some situations where you could get stuck and have unrecoverable states where there's no way to void the cache or get out of this stuck state where you've got this old thing in the browser and how do you upgrade it. And there was stuff for it, but it didn't cover all cases. So they invented service workers, which is, this is descriptive, this is prescriptive, where you're writing JavaScript and saying, I want to do these things in this order to install something, and when fetches happen, do this magic stuff. We'll look at some code in a second. But the way this starts is also quite nice. Web applications traditionally assume that the network is reachable. Crazy people. The places web content, doing that places web content at a disadvantage versus other tech. And a lot of that was because of the web's origin and where it was, and that you were doing it on a network, and so it assumed the network. But now we can't always assume the network, but we still want its benefits. So service workers are a way to leverage that. And they use a thing called web workers, which have been around for a while. It's a way to spin up JavaScript in kind of a separate place other than your web page to do long-running work or work that you don't need to hear back from right away and can communicate to that with events. So it's like that plus some defined space for installation and things like related to offline apps. So here's some code for registering a service worker. SWJS contains some code that is a service worker. And yay, it went in, if it did. And then it's posting a message to some other part of the application to say, hey, I've been installed, do whatever it is you do once you know I'm there. And then shows an error if something broke. That's the easy part. This is what can happen when you do an installation. You can listen for that moment, and then you can either invalidate your cache or load some stuff out of cache or tell the user, hey, this is great, you're now offline capable, which also happens in this space. And you can see a cache API being used here. Cache is open shell version 1. They talk about application shells a lot in offline first apps. And you can cache the assets for that. And then when you need to change it, your code has to say, okay, now we're version 2, invalidate version 1. And so there's some tricky bits here, and you're doing stuff that maybe cache manifest would have done for you. But because of that, you can do it the way you need to do it, which is maybe not known yet. So here's some offline fetching, which is probably the core of what happens in your app when people click links to your domain name while they're in your app or to assets. You need to catch those, and you need to know how to route them. You may not always be routing them locally because you can't cache everything. Can't give you all of Wiley Online Library offline for a number of reasons. But I may want to give you stuff that you've already seen. So I know that, and I've cached that for you, and when you fetch those things, I can go get that. So this is a pretty simple one of just make sure the cache has the thing that you asked for and take it out of cache if it does. An advantage this has, even if you're not offline, is just faster. Like your hard drive's a heck of a lot faster than any network connection you've got for now in the conceivable future. And then if it doesn't have it in the cache, go fetch it. So if I am online and the fetch happens, then I'll do a normal fetch and then probably recache that so that next time it'll hit the cache and not go back out to the network. And then show a frowny face maybe if it doesn't work. Next up is the file API. This is a very in progress sort of thing. Another one for giving user agents a space to deal with local files. So both kind of storing them in a protected space to give a user kind of a file system feel, and potentially with user grants of privilege, accessing portions of your hard drive to let you pull stuff off your hard drive into the web app. And this has the advantage of giving you the ability to like pre-post photos to Flickr or wherever, even though you're not online. So you've queued them up basically. And then when you do go online, your web app's already got them ready, and it goes online and ships them up and takes them out of that cache. So lots of options for building these things and making them resilient to all the different user states. Yeah, so that would be super. So let's take a look at packaging. As you know, EPUB uses zip, and it's proprietary but everywhere. There's lots of tools, but last I checked, it doesn't read stream. Does anybody know if it does? I'm curious. Got a nice room full of people. Okay, I'll keep digging. Read streamability is just being able to start at the beginning of it and just get it as it comes and do whatever you need to as it comes in. And potentially know enough to know what's ahead and jump in the stream to where that thing is. Zips don't do that, I don't think. And it's not webby. It doesn't have links and references internally that you can use to talk about other things that it knows when it unpackages. It couldn't tell you that a file was missing because it just is the compilation of the files, not that it needs to know. You know, it's dumber than that, I guess is what I'm saying. This one is exciting to me because I like MIME, or the system used in email is known as MIME. I forget what it stands for. But it's a pretty simple looking package format that we'll look at in a second that also form fields use. So if you've written a form tag and you've got file pickers, it uses a format very similar to this. It's missing some pieces, so it's not pure MIME. But it uses the same sort of streamed, this is the content delimiters, this file happens here, this file happens here. It is streamable. Well, the packaging one is, the form data one may not be. And there are references internally. So as you begin, you know this is the divider, and then packaging on the web defines a content manifest that says these are where they are, and these are their dividers, and this is their SHAs. So if you get this thing and you want to validate it, this is how you do that. And some guys from Google have picked up the work on this again, and it's well underway, which is great. So this is what it looks like. HTTP looking headers at the top, because we stole them from email. They've been around for a while. The little --J38 thing is the delimiter, and you'll see it again later. It can be whatever. It could be hi ebookcraft. It's just a string that's defined at the top, or not defined at the top. I think it's just the first appearance of it. And it says from then on out, this is where the file is broken between potentially binary content in a textual form, as well as text, as well as whatever. And web packaging gives the ability to do that for all your files into a single streamable package. These are some of the use cases that it covers. The simple ebook of a few web pages and some images, as well as like an encyclopedia in a file which like references other packages, and those could be loaded or not loaded, and you can pick them different ways. And references internally to other parts of the package graph, so that you've started with this manifest and your app, for whatever reason, knows you're only looking for Y through Z, so it's going to jump to that part of the package and pick up streaming there and not bother with all the stuff in the middle. And then signed packages, which is phenomenal, because the ability to know where that data came from and to move it around and still have some bit of security in knowing that this is what it says it is, kind of important. So EPUB plus web equals portable web publications. And these are some of its use cases, which look a lot like the other ones. This specification doesn't currently say that it has to be web packaging, because that's still in progress, and we're considering other, I say we, I'm part of the digital publishing working group, or interest group, soon to be working group, with Svea and Dave. Dave's doing all the heavy lifting. But we've defined some use cases that could use the packaging on the web spec, that could be done with other things, so we're still exploring that, the technical requirements there. But it talks about readers' needs and publishers' needs, and I link off to this. And they're a great set to read through if you are working in a library or a publisher and you have needs that you know about and you want to make sure they're addressed in some futuristic EPUB thing. You really should take a look at this. At least skim it. It's a big document. But it is broken up into these headings. We do also address archiving, distribution, and iteration of the thing. Like it's got multiple editions and multiple renditions and things. And then also escalated trust, where the EPUB or PWP thing might want to use your camera or your mic, because it's going to have you talk to the book in some way. So we want to make sure that that's a possibility in the future, the near future. These are just more portions out of that document. Constituent resources, the order in which things are provided, some of the musts and mays that are currently very soft, because we haven't finished the document yet. But I like must be available offline, right? Because nobody wants to buy a book that they can't read on the train, whatever form it takes. And these are the chunks that make up a web publication. This is not a portable web publication on this slide, that comes later. So even just a web publication needs to be online and offline. So the difference between a portable web publication and an offline web publication is that the offline web publication, you're still viewing through the browser that got you the thing in the first place. So at this point, that bullet point, it's just a web app that goes offline, basically. Plus like a manifest that makes that easy, so you're not writing a service worker and knowing all of that, perhaps. But it's not packaged in a way that you can distribute it. That's the difference. We're working on defining addressing and identification, so how do you talk about parts of the thing? I'm co-editor of the web annotation specifications, and those care a lot about this, so this one's an important one for me. Not only how you could reference it via annotation, but also how it talks about itself for packaging and reference for moving it around the internet. Metadata, which is probably that manifest file, so those two go together. Web publication APIs, so what happens once the thing is in your reading system? What does it have access to? How does it ask for more permission? What does it know about itself? Like we have the document object model, or the DOM, that understands what a document is. But there's talk of a publication object model, so you need to know more than just that page. You need to know that I have siblings, the next and a previous, or I'm in this part of the chapter, and there are reasons why, as a developer, I need to be able to look around from the current document that I'm in. And yeah, you could do that with server technology, but the point here is that you don't do that. You stay internally in this document because there may not be a server, because you're packaged and you're off a hard drive. And that also affects identification, because you've gotten it maybe over email, but it has some identifier that's on the web, but you don't want it to go out and try and retrieve stuff every time you open this thing. You want it to be internally, whatever. You want it to talk internally to itself so it doesn't get lost, like me. And then, of course, styling, layout, and pagination, and how that affects printing these things as well. And then the control of personalization data offline when you're doing a choose your own adventure and you're going to call yourself whatever in this RPG. And as you read the book, that keeps going. And there was talk of that in some other slides yesterday. So this is the PWP. I love W3C graphs. They always have these awesome drop shadows. This is some HTML, some JSON, there's an image, and the WP here is a web publication. There's a URL that defines, or that points to the thing that is the publication. It doesn't just point to the manifest, it points to like the publication. So we're working through what that means exactly. And this, as you know, is how the internet works, right? Like I asked for a web page, I got a web page back. This is what service workers get us, more or less. These are straight out of the spec. So the requests are handled locally. Right now in a browser, they would be via JavaScript. Potentially that's facilitated by a reading system, so you're not writing service workers, or we're all just not copying and pasting the same reading system service worker or pulling it in. But potentially we are for the next little while. And then the portability comes into play by adding packaging on top of that. So the ability to wrap them up in something that can be distributed and moved around with or without the web, probably initiated on the web, and then from there, some other place, email, another device, without it totally losing its mind and still working, and not always dialing home for various reasons. And then the security models around that, how do we incorporate the boundaries of this thing once it's offline? How do we vet to you that this was what you got, that's what you had when you were online, this is the exact same thing? Making sure that it isn't inadvertently getting hacked itself once it's unavailable, or if there's a way that you move it back online, or move your reading state online from that publication that was offline, how do we manage that and mitigate the risks there? And I think I've gone kind of fast, so I'm happy to answer questions, or back up, or ramble on about the JavaScript, I don't care. Thank you very much.